Hello everybody. This is a video version of the first week of distance learning notes. So the topic for today, or for this week I should say, is polynomial operations review. Our learning target. Today I will review polynomial operations so that I can successfully simplify algebraic expressions. Now we will review how to classify the number of terms for each polynomial. So we can name expression by the number of terms. Remember, your terms are separated by plus signs and minus signs. And also we have an algebraic expression means polynomial. Polynomial, many terms. Now you can have a monomial, a one-term polynomial. An example is negative 3x squared over 4. Your second example is a binomial, two terms. X cubed is your first term, minus 4x is your second term. And last but not least, you have a trinomial, which is a three-term polynomial. In this example, 5x squared is your first term, minus 4x is your second term, minus 1 is your third term. Notice, especially with negative terms, we have to include the negative sign as part of our term. When we add polynomials, you're just combining like terms. You add your coefficients, but remember to include the sign on your left. Remember, like terms have the same variable and same exponent, or same variables and same exponents. Remember, we do not change the exponents. So one example, we have 4a to the fourth minus 3a squared plus 5a in the first set of parentheses. Plus, the second set of parentheses is 8a to the fourth minus 7a. Notice how a to the fourth terms are highlighted in blue. The negative 3a squared is highlighted in green. And the 5a plus 5a minus 7a, that is in purple. Now, notice how there is a plus sign between the two sets of parentheses. If you see that plus sign between two sets of parentheses, we add or subtract like terms. Now, since there's a plus sign between the two sets of parentheses, we add our like terms. So we add the 8a to the fourth and the 4a to the fourth. So 4 plus 8, you just add your coefficients. We get 12. Now the negative 3a squared, that's the only a squared term in this whole, in either expression. Therefore, we just bring down the negative 3a squared. And again, then last but not least, positive 5a, negative 7a, 5 minus 7 gives you negative 2, and you keep the a. You don't do anything else. Just make it a. Now you can also add your two expressions vertically. For instance, we took the 4a to the fourth minus 3a squared plus 5a, wrote it on top. Then plus 8a to the fourth. Now this plus 0, that happens only because there's no a squared term in your second set of parentheses. And you have a negative 7a. And then add the coefficients of each column. Notice like terms must be in the same column going up and down. So again, 4a to the fourth plus 8a to the fourth, 12a to the fourth. Negative 3a squared plus 0, we leave it as negative 3a squared. And plus 5a minus 7a minus 2a. Now we are subtracting polynomials. Now, unlike adding polynomials, you distribute the -1. Now, we don't see it, but there is a 1 that's between the negative sign and the second set of parentheses. You need to do that before dropping both sets of parentheses. And similar to adding, add your coefficients or combine your coefficients. Remember, include the sign on the left, especially if we have a negative. And then, again, with like terms, same variables, same exponents. Do not change your exponents. All you do is just add or subtract your coefficients or combine like terms. So now for this problem, we want to figure out what is the difference of -5b to the third plus 3b squared minus 4 and 2b to the third plus 5. So now, for the moment, put parentheses around the first expression, the -5b to the third plus 3b squared minus 4. The and you replace with a minus sign, and then put parentheses around your second expression, 2b to the third plus 5. Now, notice in the next line, the first three terms in the first set of parentheses do not change. -5b to the third, positive 3b squared, -4, they do not change. But here, after you distribute the minus sign to each term in the second set of parentheses, your original term, positive 2b to the third, now becomes -2b to the third. And your plus 5 now becomes -5. Again, this is the most important step of this whole problem. Last but not least, combine your like terms, so -5b to the third, -2b to the third. Since we have two negative terms, -5 plus -2 is -7. b to the third stays the same. Positive 3b squared, just leave it alone. -4 minus 5 becomes -9. Now, distributing a monomial, you multiply the monomial, which is a single term, to each term within the set of parentheses. So you multiply your coefficients, now you will add exponents. So this first example, 3x times the polynomial x squared minus 5x plus 9. So 3 times, you don't see it, but there's a 1. 3 times 1 is 3. X times x squared, you don't see it, but the exponent of the first x outside is a 1. So 1 plus 2, we get 3. Now, 3x times -5x. 3 times -5, -15. X times x. Remember, exponent of 1, exponent of 1. 1 plus 1 is 2. So your middle term is -15x squared. Then last but not least, 3x plus 9. 3 times 9, 27. And the x, we just bring it on down for the ride. Now the box method is similar to the distribution. The only difference is really just how you set up your graphic organizer. But then it's similar to a multiplication table where you multiply your coefficients. So 3 times 1, 3. But then with your variables, x times x squared, 1 plus 2, 3. Middle term, 3 times -5, -15. X times x, x to the first, times another x to the first. That's how we get the x squared. And last but not least, 3x times 9. 3 times 9, 27. The x just comes on down for the ride. Now here, you don't see a plus or a minus sign. However, since 27x is positive, when we write our final answer, you must include this plus sign. Now, when we divide by a monomial, you're dividing the coefficients, and then with your exponents, you subtract the top exponent minus the bottom exponent. And we have to assume x does not equal 0. because if x does equal 0, well, first off, we would have 4 times 0, which is 0 in the denominator. And are we allowed to have a 0 in the denominator? No. Also, if x was 0, then your whole top becomes 0, and then we're dividing 0 by 0. Now, going back to this original problem, this is sort of like the heart method, where you make the heart. Now, in this case, it'll be 1, 2, 3. And then you split the heart into 3 parts. So 16x to the 4th divided by 4x squared. 16 divided by 4 is 4. X to the 4th divided by x squared is x squared. 4 minus 2 is 2. Now, minus, remember the minus sign came from the negative 24x to the 3rd term. So minus 24x cubed divided by 4x squared. 24 divided by 4 is 6. Now remember, you have your negative. And then x cubed divided by x squared is x. Remember, 3 minus 2 is 1. So we have x to the 1st. The last term, plus 20x squared divided by 4x squared. 20 divided by 4 is 5. Now, x squared divided by x, it goes away. Some of you in the past wrote this as 5x. This is not 5x. This is only 5, because x squared divided by x squared, think about it, what's 2 minus 2? 0. And x to the 0 power is usually 1. Now, the reverse box method is basically you're dividing what's in this section here by this part here. That's all you're doing. For the most part, you're just going with the stick. Usually you stick with this method here. Now, when we multiply two binomials, we've done this before. We use one way is the double distribution method, or FOIL. And notice with FOIL, basically you're taking your first term in the first set of parentheses, your x, and you multiply by 2x. And then take the x again, multiply by positive 3, just like what we did here and here. Here, negative 6 times 2x, that's your inner terms. Negative 6 times positive 3, those are your two outer terms. Now, unlike previous problems, we do not, I repeat, do not have a plus or a minus sign between your two sets of parentheses. This is when we multiply. So the most important question for some of these problems, do I see a plus or minus sign between my first and second set of parentheses? If the answer is no, then we multiply. So in this case, we multiply x times 2x. There's your 2x squared. Remember, x to the first, that's how we get the x squared. 1 times 2 is 2. Similarly, x times 3, this is 1x. 1 times 3 is 3. And x comes on down for the ride. Here's the second part. Negative 6 times the positive 2x. Negative 6 times 2, negative 12. And x comes on down. And then negative 6 times positive 3. Negative 6 times 3, negative 18. Now what we do is we combine any like terms, which in this case would be the positive 3x, negative 12x. Watch your signs, please. 3 minus 12, get a negative 9, keep your x. And again, usually these two middle terms are the only two terms that you will be combining for the most part, 9 out of 10 times. There might be other problems where that might not always be the case, but usually when we're multiplying two binomials, the first term's an x, and the first term is another x. Usually you are combining the two middle terms. So now the 2x squared, bring it down for the ride. positive 3x minus 12x minus 9x, and negative 18, keep it as negative 18. Multiplying polynomials by way of the box method. So you take your first polynomial, or binomial in this case, 3a minus 1, write it across, so the 3a goes in the first column, negative 1, second column. Then for your rows, a is in the first, negative 5 for the second row. Now, you could have this as positive 3a, negative 1, a minus 5. So it doesn't matter how you line up. If you put the first binomial here or down here, second binomial could go here or down here. The most important part is these steps right here. So a times 3a, 3a squared. Notice again, a times a is a squared. A times negative 1, negative 1a, or just negative a. 3a times negative 5, negative 15a. And then negative 5 times negative 1 is a positive 5. Now the 3a squared, that term stays. The middle term, negative 15a minus one more a. So 15 negatives, one more negative joins the bunch. You have a grand total of negative 16a. And then 5, you don't see the sign, assume it's a positive. So the product of 3a minus 1 times a minus 5 is 3a squared minus 16a plus 5. And again, since there's no plus or minus sign between the two sets of parentheses, that's when we multiply. Now this last slide, the multiplying binomials area model, what's going to happen is you're going to use your two binomials as algebra tiles. So notice x plus 3, positive x, that's your one rectangle, and positive 3 are the three little squares. X minus 2, positive rectangle, but then you have two negative, the shaded squares. And then we multiply x times x, x squared, x times 1, 2, 3 is 3x. So 3 rectangles. And then you have this x rectangle times 2 negative squares. So positive x times negative 1, negative 1x, and another negative 1x. So we have negative 2x. And then positive 1 times negative 1 is a negative 1. We do that 3 times for this top row, 3 more times for the bottom row. So that's how we have 1, 2, 3, 4, 5, 6 negative little squares. So we have negative 6 for the last term. Now, your middle term, positive x, that's because you have 3 positive rectangles, so 3 x's, and 2 negative rectangles, negative 2x, so 3 minus 2 is 1. And then this big square, since it's not shaded, that's a positive x squared. So this is another way to set up your binomial multiplication using algebra tiles or algebra shapes. Now, there's a math-based polynomial operations review, which will be posted. Also, there will be an e-cart quick check. And again, both of these assignments should be completed. And this is the way we can help you get feedback. And last but not least, you have additional independent practice on these 3 slides. Again, the first set of slides, you add or subtract. Now again, with subtraction, distribute the minus sign to each term within the second set of parentheses. Now for number 4, be very careful. Subtract the first polynomial from the second polynomial. Look for subtract from means the 2x to the third plus 5x squared minus 4. That is actually going to be what you write first. minus sign, then your second set of parentheses will contain this first polynomial, 4x cubed plus 3x minus 5. And then the fifth problem, you're adding these two. Once you get your sum for these two polynomials, whatever that is, then you subtract it to the third polynomial. Again, what you can do, since these first two are only separated by a plus sign, you can just drop parentheses, combine the like terms for the first two, then distribute the minus sign to each term within the third set of parentheses. But notice, especially for that first term, minus negative, what's really going to be the sign for this first term? And then you have these two positive terms, which once you multiply by the negative sign, they should become negative, but this guy should be positive. And then you combine your like terms. So anytime you see a plus sign or a minus sign between two sets of parentheses, you're just adding or subtracting or combining like terms. This one, 6 and 7, you are multiplying. So basically you're distributing the monomial to each term within this case polynomial, this case binomial. Now be very careful. 5m squared times 4m squared minus 3n squared. First term, you should be okay. This second term, watch your variables. Are they like or are they not like? 8, 9, and 10, you're dividing your top monomial or polynomial by your monomial in the denominator. And then for the last one, area divided by width will get you your length. And then these last problems are also practice of multiplying using distributive method, FOIL, or box. And for number 15, I would use box method. And for some of you, you have actually seen some of these problems before. As always, feel free to email me if you have any questions. Thank you so much.